Hello everyone, welcome to Dr. B.R. Ambedkar of University. Today we are going to discuss about the Taylor's theorem, and it is one of the important topic in the differential calculus. So now first let us go to the Taylor's theorem. So what is the Taylor's theorem statement? If f is a function f map a comma b to R such that f of whole power of n minus 1 continuous on a comma b and f for n minus 1 is derivable on a comma b, that is f4 of n is exist on open interval a comma b and p is a positive integer and there exists one number c is belongs to open interval a comma b such that f of b equal to f of a plus b minus a by 1 factorial into f dash of a plus b minus a whole square by 2 factorial into f double dash a plus b minus a whole cube by 3 factorial into f triple dash of a plus so on b minus a whole power of n by n minus 1 factor into f4 of n minus 1 into a plus r of n. So here that r of n is Rn is the remainder. So what is the remainder means, but b minus a whole power of p into b minus c whole power of n minus c and f4 of n of c by p into n minus 1 into factorial. So this is a statement of the Taylor's theorem. Okay, now let us go to the proof. So we can define the one function pi map a comma b to R. It is defined by pi of x equal to f of b minus f of x minus b minus x by 1 factorial into f dash of x minus b minus x whole square by 2 factorial into f double dash x plus so on minus b minus x whole power of n minus 1 by n minus 1 factorial into f power of n minus 1 into x minus a into b minus x by b minus x by b minus a whole power of b. So here the important task is here, what is that? Let us assume the function pi of x is that important, and where here the constant a is there, no. So where a is chosen, that pi of a equal to 0. So how we can find the a value means, that is pi of a equal to 0. Here f power of n minus 1 is continuous on closed interval a comma b and its derivative of open interval a comma b. That implies what is that? F and f dash and f double dash so on f power of n minus 1 all are continuous on a comma b and its derivable on open interval a comma b, and also b minus x by b minus a whole power of p is a continuous on closed interval a comma b and it is also derivable on open interval a comma b, and for each positive integer p, then pi of p equal to 0. Therefore, pi of a equal to phi of b. Thus, the function pi is such that pi is continuous on closed interval a comma b and pi is derivable on open interval a comma b and pi of a equal to pi of b. So, let us see from these three here, pi of a equal to pi of b and pi is a continuous and pi is a derivable. Pi is continuous on closed interval a comma b and pi is a derivable on open interval a comma b and pi of a equal to pi of b. And we know that previous studies Rolle's theorem. What is the Rolle's theorem? Pi is continuous on closed interval a comma b and pi is derivable on open interval a comma b and pi of a equal to pi of b. Then there exists one element c belongs to open interval a comma b such that pi dash of c equal to 0. So, that means we are getting that pi of a equal to 0, that implies we are getting f of b minus f of a minus b minus a by 1 factorial into f dash of a minus b minus a whole square by 2 factorial into f double dash of a so on minus b minus a whole power of n minus 1 by n minus 1 factorial into f power of n minus 1 of a minus a equal to 0. So, let us take the condition, this is the 2. Now, this is the pi of x. we define one function. No, now we are going to derivation of pi of x. So, derivation of pi of x is nothing to pi dash of x. Now, let us see the pi dash of x. So, this is pi of x. Now we are going to derivation f of b, it is a constant. So, constant derivation is always 0. No? So, we are getting 0 and minus f of x derivation is f dash of x, and in the same way here b minus x by 1 factorial into f double dash of x. Here we have to apply the uv formula. What is the uv formula? U dash v plus v into u dash. So, in the same way we are using this one and we are getting pi dash of x equal to minus f dash of x and minus of minus f dash of x plus b minus into f double dash of x and minus of b minus x into f double dash of x plus b minus x whole square by 2 factorial into f triple dash of x, so on, and minus b minus x n minus 2 by n minus 2 into f power of n minus 1 plus b minus x whole power of n minus 1 by n minus 1 factorial into f power of n plus, and here the one more term is there, no, minus a into b minus x by b minus a whole power of p derivation. Let us see that derivation is become a p by b minus c whole power of p, this is a constant we are writing outside, and b minus x whole power of p, b minus x whole power of p derivation is p into b minus x whole power of p minus 1 and minus will become, and this is the derivation of the pi dash of x. So, this is pi of x and this is a pi dash of x. Now, let us see that pi dash of x after the simplification, and we are getting b minus x whole power of n minus 1 by n minus 1 factorial f power of n by x plus p into a into b minus x whole power of p minus 1 by b minus a whole power of p. Now, as per that Rolle's theorem, we got what is that pi dash of c equal to 0. No? Now, this is pi dash of x. Now, let us see that pi dash of c equal to 0. So, from there we are getting after the simplification, and we get a equal to b minus c whole power of p into b minus c whole power of n minus p and f power of n of c by p into n minus 1 factorial, and this is that a value. So, this let us come substitute that a value in equation 2. So, this is the equation 2 after using that pi dash of x, and we got the a value. So, a value we have to substitute in 2. So, this is a 2 equation 2. So, from there we are getting that pi of b equal to f of a plus b minus a by 1 factorial into f dash of a plus b minus a whole square by 2 factorial into f double dash of a plus so on plus b minus a whole power of n minus 1 by n minus 1 factorial into f power of n minus 1 into a plus b minus a whole power of b minus c whole power of n minus p into f power of n of c by p into n minus 1 factorial. So, how we can get in? After first it is verify the Rolle's theorem, and after that Rolle's theorem as per the condition there exists c belongs to a comma b, pi dash of c equal to 0. No? So, we are finding that pi dash of x, and after that we substitute pi dash of c equal to 0 in pi dash of c equal to 0 and we get the a value, and similarly that substitute that a value in that equation 2. So, this is the Taylor's theorem, and here the remainder Rn. So, here the part is there, no, b minus c whole power of p and b minus c n minus p into f power of n of c by p into n minus 1 factorial, that is called remainder Rn. It is also called Skoll-Roche form of the remainder. When if you are substituting that p equal to n in the above equation, here the remainder Rn is there, no. So, if you are getting p equal to n, so if you are getting substitute that p equal to n and we are getting b minus a whole power of n and f power of n c by n into n factorial. So, this is called that Lagrange form. So, this is in place of Rn we substitute in our remainder p equal to n and we are getting that Lagrange form of the remainder Rn, and if you substitute p equal to 1 and we are getting Cauchy form of the remainder Rn. Same thing in the formula Rn remainder is there, no, if you are substituting p equal to n, that is Lagrange form of the remainder, if you are substituting that p equal to 1 and Cauchy form of the remainder Rn. So, if you are substituting that p equal to 1 and we are getting Cauchy form of the remainder Rn equal to b minus a into b minus c whole power of n minus 1 and f power of n of c by n minus 1 factorial. So, this is the Taylor's theorem. So, using Taylor's theorem we find out the remainder Rn and Lagrange form of the remainder Rn and Cauchy form of the remainder Rn. The small there is the difference between, if we are substituting that p equal to n and we are getting the Lagrange form of the remainder Rn, and if you are substituting that p equal to 1 and we are getting that Cauchy form of the remainder Rn. So, this is the Taylor's theorem. And next to go to the Maclaurin's theorem. So, just now we finished the Taylor's theorem, no? And now we are going to discuss about that Taylor's theorem. Let us see the statement of this Taylor's theorem. If the function f is defined on closed interval 0 comma x is such that f power of n minus 1 is continuous on closed interval 0 comma x and f power of n minus 1 is derivable on open interval 0 comma x, and p is a positive integer and there exists one theta belongs to open interval 0 comma 1 such that f of x equal to f of 0 plus x by 1 factorial into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus so on x power of n minus 1 by n minus 1 factorial into f power of n minus 1 in 0 plus x power of n into 1 minus theta whole power of n minus p by p into n minus 1 factorial into f power of n of theta x. So, this is the Maclaurin's theorem. So, this is the Taylor's theorem statement. This is the important topic, and in the examination also they will ask state and prove the Taylor's theorem. Okay. So, we have to write the statement and we have to write the proof also. So, just now we discussed about Taylor's theorem, now we are going to discuss about the Taylor series. So, what is the Taylor series? Let us suppose that the function f is defined on closed interval a comma a plus h and it is possesses the continuous and derivative of every order in closed interval a comma a plus h. Then, so what is that? As per the Taylor series, f of a plus n h equal to f of a plus h by 1 factorial into f dash of a plus h square by 2 factorial into f double dash of a plus so on h power of n by f power of n of a into f power of n a is called what is a Taylor series. So, it is very important in the problem they will ask that expand the function by Taylor series. So, Taylor series once again I have explained, f of a plus h equal to f of a plus h by 1 factorial into f dash of a plus h square by 2 factorial into f double dash of a plus so on h power of n by n factorial into f power of n of a plus a is called what is a Taylor series. And we know that what is the f dash of a, f double dash of a. F dash of a is the first derivative of f of x at the point x equal to a, and f double dash of a is nothing to what is that x second derivation at the point x equal to a. Now, let us see the proof of this theorem Taylor series. So, let us suppose the function f is defined on closed interval a comma a plus h and it is continuous derivatives of every order in a comma a plus h, then for all n belongs to n and we have f of a plus h equal to f of a plus h by 1 factorial into f dash of a plus h square by 2 factorial into f double dash of a plus h power of n minus 1 into n minus 1 factorial into f power of n minus a plus Rn. Here what is the Rn means? So, previous we learned the remainder. So, where Rn is called the Taylor's remainder after the n terms. So, this is the n terms. So, after the n terms we are getting that is called that remainder. So, let us take that Sn equal to f of a plus h by 1 factorial into f dash of a plus h square by 2 factorial into f double dash of a plus so on h power of n minus 1 by n minus 1 factorial into f power of n minus 1 into a. Then f of a plus h is become. So, this first part is we are taking that Sn. No? So, Sn and the left to the last term after the n terms we are taking that Rn. So, the totally that f of a plus h equal to Sn plus Rn. Now, if Rn tends to 0 as n tends to infinity, then we can apply that limit n tends to 0 Sn is equal to f of a plus h is a finite quantity. That is the sequence Sn is convergence to f of a plus h, that is the series f of a plus h by 1 factorial into f dash of a plus h square by 2 into f double dash of a plus so on h power of n minus 1 by n minus 1 factorial into f power of n minus 1 a plus so on. It is also convergence to f of a plus h. Why? Because the Sn we assume no, the Sn is first n terms. So, Sn is convergence to f of a plus h no. So, similarly the total that Sn is convergence to f of a plus h. From this we can conclude that if f is possesses the continuous derivative on of every order in a comma a plus h and the remainder Rn after the n terms tends to 0 when as n tends to infinity. So, this is the Rn in the equation 3 after the n terms is that Rn is there no, that Rn is tends to 0. What is the meaning of tends? It is reaching to 0, but it is not reached, and we have one example. India is a developed country, but it is not developed. In the from since we childhood we are learning India is a developed country, developing country, but it is not developed. So, in the same way here Rn after that n terms Rn is tends to 0, but it is not equal to 0 as n tends to infinity. So, this is that. So, from there we are getting what is that, if that after the n terms Rn is tends to 0, then we are getting f of a plus h equal to f of a plus h by 1 factorial into f dash of a plus h square by 2 factorial into f double dash of a plus so on h power of n by n factorial into f power of n a plus so on. So, this is called that Taylor series. So, remember this is the important formula. So, if any question they are asking about the Taylor series, you just remember the formula. What is that? Once again I explain. F of a plus h equal to f of a plus h by 1 factorial into f dash of a plus h square by 2 factorial into f double dash of a plus so on plus h power of n by n factorial into f power of n of a. So, here what is the f dash of a? Once again I explain. The first derivative of f of x at the point x equal to a, and what is the second derivative means second derivative, what is the f double dash of a means second derivative of f of x at the point x equal to a. So, students, once you have to remember the Taylor series formula. So, this is the Taylor series formula. Now, come to that Maclaurin series. There is small difference between the Taylor series and Maclaurin series. So, this is the Taylor series f of a plus h no, just we have to substitute a equal to 0 in the Taylor series and we are getting that Maclaurin series. So, if you know the Taylor series, then automatically you also getting that Maclaurin series. What is the difference between here Taylor series we are expanding at the one point, but Maclaurin series we are expanding the function at the point 0. So, that is the difference between at the point 0 we are expanding the Maclaurin series and at the some point we are explaining that Taylor series. So, in a equal to 0, if you are substituting that a equal 0 in Taylor series, then we are getting that Maclaurin series. So, this is that Taylor series now we are substituting that a equal 0 and we are getting f of h equal to f of 0 plus h by 1 factorial into f dash of 0 plus h square by 2 factorial into f double dash of 0 plus so on plus h power of n by n factorial into f power of n of 0 plus so on is called what is that Maclaurin series. In Taylor series we are substituting a equal 0 and we are getting that Maclaurin series. Okay. Now, we are going to expand e power of x by using the Maclaurin series. So, expand the e power of x and we are using in so many in problems expand the e power of x. So, now we are going to expand the e power of x and using the Maclaurin's expansion or using the Maclaurin series. So, let us take the first case one. If x is not equal 0, let us take the set of one set capital X equal to closed interval 0 comma x for x is positive and when in the interval x comma 0 when x is negative. So, let us take the function f is mapping from S to R and it is defined by f of x equal to e power of x, and we know that the derivation of e power of x, that every time that is e power of x only. E power of x first derivation, that is e power of x, second derivation also e power of x, and third derivation is also e power of x, and so on. The nth derivation of e power of x is also become e power of x. So, therefore, f power of nth derivative of e power of x, that is become e power of x, and for all x is belongs to capital X and n is belongs to capital N. Now, in place of x, if we are substituting 0 and we are getting e power of 0. So, e power of 0 is nothing to 1 and f power of n 0 equal to 1 for all n is belongs to n. Now, Lagrange form of the remainder Rn after the n terms h power of n by n factorial into f power of n a plus theta h, that equal to x power of n f power of n by n factorial into that we can write x power of n by f of theta x is become e power of theta x. F of x equal to e power of x, and the nth derivative of f of x is also e power of x, no. So, in the same way here we are getting e power of theta x. Now, we have to prove that Rn tends to 0 as n tends to infinity. Now, let us take that series un equal to x power of n by n factorial, then u plus n1. So, u n plus 1 means in place of x we have to in place of n we have to substitute n plus 1. So, that is become x power of n plus 1 by n plus 1 factorial. So, here we are using that u n plus 1 by u n, no. So, u n plus 1 by u n, and we are getting what is that x by n plus 1. Now, apply the mod. So, mod of x by n plus 1, and in place of n plus 1 we are taking n is common and we are getting n into 1 plus 1 by n. Let us see the denominator n plus 1, no, we are taking n is common. So, n of 1 plus 1 by n. Now, apply the limit n tends to infinity. So, when you are applying to the limit n tends to infinity, that we are getting 0. Mod of un plus 1 by un is tends to 0. Why? Because in place of n we are substituting infinity, no. So, 1 by infinity, that is 0. So, un plus 1 by un value is 0 and that is less than to 1. So, as per that we can take the limit n tends to infinity un equal to 0. So, that means the remainder Rn is tends to 0 as power of n tends to infinity. Now, from case 2, let x equal to 0, then Sn equal to 1 plus summation of k equal to 1 to n x power of k by k factorial equal to 1, and limit n tends to infinity Sn equal to 1, and that we can write e power of 0 and that we can e power of x. So, therefore, f has a Maclaurin expansion from x belongs to minus h comma h from the case 1 and 2. This is the case 1 and from the case 2, and we can write that expansion of the e power of x equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on x power of n by n factorial. This formula we can use it in many problems, not only in the UG level and in the PG level and in the intermediate level also. We know that expansion of the e power of x, but here we learn what is that, how we can get that e power of x equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on. So, this is the important topic, and that expansion of the e power of x by Maclaurin series. And the one more thing, sine x. So, this formula also we are using, we know the sine x expansion, but we are using by Maclaurin's theorem how we can derive the sine x expansion of the sine x. So, first let us take that x is not equal 0, and in the same way we are define the one function that capital X equal to 0 comma x closed interval for x is greater than or equal to greater than 0, and x comma 0 closed interval for x is less than to 0. Then for the function f map x comma are defined by f of x equal to sin x, and sin x derivation, f of x derivation is become f dash of x, sin x derivation is cos x. Next, second derivation we are getting cos x derivation is minus sin x. See, listen, f of x equal to sin x and f dash of x equal to minus cos x, and f double dash of x equal to minus sin x. F of x equal to sin x, f dash of x equal to cos x, and f double dash of x equal to minus sin x. Again, f triple dash equal to, that is also become minus sign. So, alternatively that plus minus plus minus plus minus, you know. So, in the same way we can say the nth derivative of sin x is become f power of n of x equal to sin of x plus n pi by 2. In place of n equal to 1 we are getting first derivative. Suppose we are getting n equal to 1, let us see what will happen. Sin of x plus pi by 2, sin 90 plus x, sin 90 plus theta, that we can write cos theta, no. So, in the same way sin 90 plus theta, 90 plus x is become to cos x, that is a first derivative. Let us see the, if you are substituting that n equal to 2. So, what will happen, sin of x plus 2 pi by 2, the 2 to get cancelled and we are getting sin 180 plus x. So, in sin 180 plus theta, so that is become to that minus. So, this is that formula of f of x equal to, we can write sin x equal to f of 0 plus x by 1 factorial into f dash, x by 1 factorial into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus so on x power of n minus 1 by n minus 1 factorial into f power of n minus 1 of 0 plus r of n. R of n we can know that it is a remainder. Now, first we have to prove that the remainder is tends to 0 as x tends to infinity. So, here the remainder that Rn, so Rn equal to x power of n by n factorial into f power of n of theta x, that is x power of n by n factorial into sin of theta x plus n pi by 2, and where the theta is in between of 0 comma 1. Now, let us apply the mod on both sides, that we are getting that mod of Rn is less than or equal to mod of x power of n by n factorial. Here the sign value, the range of the sign value is always that in between of minus 1 to 1, and we are taking that 1 and we are getting that mod of Rn is less than or equal to mod of x power of n by n factorial. So, now apply the limit. So, limit n tends to infinity, x power of n by n factorial is tends to 0. So, therefore, Rn tends to 0 as n tends to infinity. Now, therefore, for x is not equal 0 and sin x equal to f of 0 plus x by 1 factorial into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus so on x power of n by n factorial into f power of n of 0 plus so on. Now, we can get that x by 1 factorial minus x cube by 3 factorial plus x power of 5 by 5 factorial. Why? Because here this is that second derivation is going to 0. Why? Because sin 180 is nothing to what is that, e equal to 0. So, therefore, here x square by 2 factorial is not there. Why? It is a second derivative of sin x, it is 0. So, in the same way when at the point x equal 0, it is going to 0. So, that is why the sin x expansion is become x by 1 factorial minus x cube by 3 plus x power of 5 by 5 factorial. Why? Because see already here f of 0 is 0 and f dash of 0 is become 1 and f double dash of 0 is 0 and f triple dash of 0 is equal to minus 1 and so on, we are getting that. So, this is the expansion of the sin x. Thank you.